Hi, my name's Everett. Welcome to the shop. This week we have a project I brought home from work with an oil cooler off of a Dodge pickup. This is an older one. It's about mid 2000s. It's got the 5.9 liter Cummins inline 6 engine in it, and behind those engines they had the 48RE automatic transmission. The 48RE actually had two oil coolers in it. One was actually an oil to coolant heat exchanger it was also called the torque converter cooler. And the other one was mounted up near the radiator. That was the second one. That was the oil to air cooler. And from there it went back into the return circuit, which became part of the lube circuit in the transmission. Now, one of the things is the transmission cooler lines have short rubber sections in them. Over time, and especially here in Canada, especially in Alberta where we have such wide temperature swings, what happens is those fittings start to leak a little bit where the rubber goes onto the steel lines. When you have to change them, you have to undo the flare fittings on either end, remove it, replace it, and tighten them back up again. That's all fine and dandy as long as you can get the fittings off without damaging the fittings that they're going onto, taking the lines off of the fittings. And unfortunately, it's a fairly common problem with the torque converter cooler on the 48REs. I have one right here that I need to redo both of these flare fittings. They've both been kind of chewed up. What I'll do is I'll put in a close-up view here of what they look like. And as you can see, the one, you can see it's really badly twisted off, and the other one is not that much better. So I'm going to actually repair both of them. This cooler, retail here in Canada, is about $1,400 Canadian. I know you can get aftermarket ones for a little bit cheaper or whatever, but still, I mean, they threaded the aluminum hex fittings here. They just, on whatever CNC machine they're using, they just threaded them and put the flare fitting on that, which on assembly, when everything's nice and clean, is fine, but you let the thing work out in the world for a little while, and what happens is you get a little bit of rust in there. The rust grabs the aluminum as you try and take it off and just twist the threads off. So what we're going to do is we're actually going to take this and we'll cut the flare fittings off, these external flare fittings. And then what we're going to do is we're going to pick up the center, pilot drill, tap with a 3/8 18 National Pipe Thread tap, and then we're going to use these. These are brass fittings. They're 3/8 NPT on one end and flare fitting on the other end, 1/2-inch flare fitting. You'll never have this problem again because brass doesn't react to steel the same way aluminum does as far as galling, at least in the experience I've had as far as automotive stuff. So I know this looks silly, but it actually works. I've done more than one like this. I've got the cooler clamped to the table and along the end tabs. I'm going to brace the hex portions here, these fittings. When it comes time to tap, I will brace those, but you'll see how I do that then. What I need to do now is actually, believe it or not, just cut this end off. I'm going to do that with a hacksaw. And in order to make sure the chips and such don't collect in the actual cooler, we're going to make sure there's a constant flow of air through the cooler this way. When I go to do this fitting, I'll just reverse the fittings, or reverse the airflow, and it'll go this way instead because everything will be blown out this end already, so I should be able to blow that way. Now, as far as putting air in, I could use a regulator if I had one here, but I don't, so I have my air blower hooked up, and then just use I'll need a different zip tie. That will keep a constant flow of air through it as long as I keep. There we go. Simple, easy peasy. The downside of this system is, unfortunately for you listening at home or whatever, the air compressor will be kicking on every now and then. I don't have a huge air compressor, so expect it to cycle on and off. There we go. There goes the compressor. Okay, we see some transmission fluid coming out, so that's a good sign. Means we have good airflow. I know I could probably just mill this off. Quicker to do with the hacksaw. Touching off there. Now this is a 5/8 end mill, so theoretically should be able to do it in a couple passes. See a 30 thou depth of cut. Yeah, I can see it scratching and cutting there. I'm going to do 2 passes to make sure it gets it all cleaned up. I'm going to take another 30 thou. Actually, not 40 thou. So overall we're taking about 70 or 80 thou off the top. Now the fitting that we're putting in will be slightly taller. That doesn't really matter considering the fact that the tubes themselves give us a little bit of forgiveness. We've got a little bit of play to work with there. There we go. End mill comes out. Now there's a reason I'm keeping the air going just for the moment. That's because I wanted to give this hole a quick deburring, and I wanted that chip to come out. Okay, we'll let that pause, give the air compressor a chance to catch up. Now that the air compressor's caught up, I'm going to give it a little bit more air, and then I'm just going to take the burr off the edges. And there goes the air compressor again. Now it's fine that the air compressor is running right now, because this also, at this point now I have to do my lineup. A while back, in one of my previous videos, I made just this little simple hole center finder, and well, a fairly simple and crude tool. For something like this, it's plenty accurate enough. And it just so happens that I made it with a 5/8 shank. This hole, or the tapping this hole, is not an ultra precision operation. So, as far as if I'm within a couple thousandths, it will be just fine. There you go, our table is locked. Can now put the drill bit in. Tap drill size for 3/8 NPT is a 37/64. I know there'll be somebody who's going to be angry at me for using a 37/64 drill bit and a 5/8 collet. I'm sorry, but it's all I got. We're not going that deep anyway. And we're actually not taking a whole pile of material off. We're going into aluminum. At some point I'm going to have to break down and buy a bigger drill chuck for this mill, but for now this is what I have to work with. Set that up. That should be deep enough. So that'll be deep enough to tap our hole. Now, one other little tool I made a while back, and this is before I even started video or anything, is this little center. I don't have a spring-loaded center for taps yet, so this is what I have. It's made to a 3/4 inch outside diameter. So I can actually put it in the 3/4 inch collet. And this way I can use the quill as a centering device, like that, as I start my tap. Unfortunately, I won't be able to use a tap handle because a tap handle this size will interfere with my air fitting. So I'm going to have to start it and use just an open-end wrench. It's nice because you can see the air actually flowing up through. It actually blew a bit of the WD-40 away. But hopefully there's still enough in the flutes to do what they need to do. There goes the air compressor again. So that was using the quill to help keep that centered as it was threading. At this point, what we're going to have to do is pause, and I need to add some bracing to this fitting. You're going to laugh at me when you see this, but trust me, it works. What I've done here is I've actually taken and buttressed up another block. I can now put some torque against this, and the wrench will take the torque, not the cooler core itself. So we can carry on now with our tapping operation. The problem with the tapered thread is the further you get down, the harder it is to cut. The fitting we're going to use is one of these guys. It's a 3/8 NPT on the one end and the 1/2 inch flare on the other. Nominal flare, that is. 1/2 inch line goes onto it. I'm probably going to stop tapping fairly soon here because I'm down to about there on the tap. So I'm going to give it a couple more threads, a couple more turns. I'm noticing it's getting tighter to work with, at which point then we'll call it quits on this particular fitting, and then we'll start working on the other one. So now that we know that the thread is a decent enough length, or depth in there to create a good seal and give enough structure to the joint. What we're going to do is, this might be running, what we're going to do is we're going to make a chamfer on the end of the hole, just for a little bit of lead in. Countersink here, just going to lightly touch it. There we go. What that does is that just gives it that nice little professional looking finish. Okay, so rather than bore you with doing the same exact thing as I've done to this hole, to this fitting, what I'm going to do is I'm going to cut the camera right now and bring you all back in once I'm actually getting closer to the end and you can see the finished product really. Fittings will just thread in like so, well, once I actually get them started, on both sides. You'll never have this problem again with thread engagement issues. And one of the handy things about this too is, yeah, even if these do get messed up on whatever, for whatever reason, you can replace them. So now all I need to do is, what I'm going to do is I'm going to take this to work and I'll use the Teflon pipe sealant, liquid pipe sealant on these fittings. All we need to do now is put the backing plate back on. There you have it. So that's about as much time as I have for tonight. The cooler is ready to go. Just have to, well, apart from sealing the threads with Teflon thread sealant, then it's ready to be used again. These coolers, like I said before, in Canada, from Chrysler, these things are about $1,400. I know you can get them aftermarket for a bit cheaper, whatever, but for the price of 2 brass fittings and a little bit of time, we can make this work. So, otherwise, it's been it's been an interesting evening watching the baby monitor here, because again, my wife has been in bed for a while now, and so I've been watching this so that she can have a chance to sleep, and thankfully he's been sleeping even though he's been tossing and turning. Anyway, thanks for watching, thanks for subscribing. If you like what you saw tonight, if you could find it all useful, or if it gave you an idea for something else, by all means click the like button. Comments are always welcome. Again, it's getting down to the Christmas season, so it's going to be busy with that, with family coming and trying to arrange with different things. So I will try to keep up as best I can with getting the videos out on time. So thanks for watching, thanks for subscribing, see you next week.